Hey y'all, Kadir here, and today I'm going to be explaining how our team used the vision sensor to automatically lock on and track the goals. So it's going to look something like this, where right now the robot is in a line, it's just facing the general direction of the goal, and I can press one button on my controller, and it actually goes and aligns itself perfectly automatically. So again, this will save a lot of time aligning, and actually there's another example of where it can do it successfully from over across half the map. So as you can see clearly, it's not even facing the right direction, but as soon as I press that button, it's going to go align itself perfectly. So let's take a look at the logic behind this and then the code. Okay. Actually, first I would like to go over a few of the starting points. So I wanted this code to act only when I am pressing down the down button on my controller. And the way I did this was when the button is pushed down, I turn on the motors and I actually put the whole thing for my whole code inside a while loop. And what's happening here is I'm just looping this program over and over while the controller down is pressed. And if it's released, it's going to stop. And there's another block saying that when it's released, it's going to stop the motors for my left and right drive. Okay, so let's take a look at how the logic behind this thing works. So here, I'm just going to screenshot like a blank page, and let's first understand how the vision sensor works. The vision sensor is just a camera. Okay, so it's going to be a single point, and what's going to happen is you have a field of view. So I'm going to draw the goal in red. So it's going to look something like this, and let's say that's covered in. Okay, so the field of view for the camera might be something like this, and as long as your camera's field of view is, or as long as the goal is inside your camera's field of view, your camera will be able to detect it and track it. Programming the vision sensors itself is not particularly a complicated task. There's only a handful of blocks that go with it. It's just the logic that gets everyone. So when you plug in a vision sensor, you're actually required to first calibrate it, and you do that by connecting your micro USB cable to the vision sensor directly. And there are a bunch of tutorials on YouTube, and I'll probably make one to show you how to calibrate the vision sensors. But once you calibrate the vision sensors, the way it works is it actually takes multiple pictures per second and compares those pictures with each other to do stuff you may want. So the way it works is you take a snapshot of, let's say, like red goal, and the red goal is there as an option because I calibrated it and I want red gold to be an option, right? So I can calibrate up to, I believe it's 7 colors. Yeah, right now it says it's disconnected, but you can actually get a preview of the image here and do stuff with it. But yeah, right now I only have it set to identify the red goal. So in my program, what I would do is I would take a snapshot of it, which is just a picture, and I would set the object item to 1. This is an important step, okay? Because if you were to look at the goal, it's got a top part, and it's connected by a pole, and then it has a bottom part, which is significantly larger than the top part, right? When the vision sensor sees this, it's going to identify, let me use a different color. It's going to identify like this part as one entity, and it's going to identify this part as one entity. Setting the object to, okay, now let me close out of this. Okay, yeah, setting the object item to 1, what it does is it just sets the object in concern to the largest item, which is going to be this bottom thing right here. And again, like, because you know where the bottom thing is, and this is a fixed thing, fixed object, you also know where the top is. You don't really have to work toward that. As long as you can target for the bottom, you'll be fine. So let's look at this logic in 2 dimensions first. Okay, let's pretend like we have a line, right? and we have 2 points on the line ranging from, or let's just say this is a line. Let's worry about the points later. And in this line, I have a camera, and this is what the camera sees. This is the field of view of the camera. Okay, and I'm going to put this red dot like right there on this line, and I'm also going to draw a crosshair on the camera. Okay, so let's imagine that we have a motor. Um, Let me use this color. So we have a motor. Let me say motor 1, and it can move the camera in this direction or in this direction. It's programmed to move the camera either to the left. So to the left it's going to be negative power, and to the right it's going to be positive power. Okay, so now that we know that information, let's look at the camera. Okay, so let's say the camera can see 200 pixels. So this would be negative 100. Let me make this a slightly smaller size. This is going to be 100, and our center is going to be 0. Don't worry about the top and bottom for now. We're only doing one dimension. So the center is 0. What our vision sensor does is it has the option to give you different properties of the object, right? So we have the width, the height, the center x, center y, so on and so on. The only thing we're really concerned about is the center x here, the center of the object. We know that the vision sensor can give us that information. So we know that the center of the object is, let's say, 20 pixels, right? So the distance between the center of the camera and the center of the object is 20. And that is a number we can work with. And let me explain why in just a second. So because we know this number, we know exactly how far off we are. And what we're going to do is implement an algorithm called proportional control. Proportional control to control our motor so it always stays on track with that red target. Alright, so let's look at this algorithm for just a second. The simplest way to put it, you have an input value, let's say x, and it's going to be mapped to an output value. Very simple. It's pretty much a linear function if you think about it. So you have an x value and it returns a y value. And we actually have a perfect linear function with a slope of 1, and you'll see why in just a second, but these power values, this negative 100 and 100, are actually the powers we need to control the motor. So if we put, and I'll tell you guys in just 1 second why this is useful information, but let's say we give this x variable a value between negative 100 and 100. Oh, that doesn't look right. So let's just say negative 100 to 100. I'll draw an arrow. It's going to return as a power for the motor. So this number right here is actually the distance from the center. And let's see how this works. Okay, so right now the distance is 20, right? And actually this is going to be negative 20 because the position of this is in the negative direction. So what if I take the distance from the center, which is going to be the 0 position, so I'm going to write down 0 minus center, and that's going to be a variable, center x, because this is the x-axis. So if I look in VEX code, center x is going to give me that position. So 0 minus center x, so the center of the camera minus the center of the object, and again, this 0 can be anything. It is actually a different value in the VEX camera, and that's mentioned in the documentation on their website, but I'm just using 0 as a means of explanation. Okay, so our power for our motor, So set velocity to is going to be 0 minus center of x. So let's think about this for just a second. In this exact situation, what's going to happen? The motor is going to have a power of negative 20 because that's the distance from the center of the x. So this means that the motor is going to start moving to the left. And I'm actually going to erase this frame that I drew here. Well, I guess the middle line is going to stay. Yeah. Okay. So, oh, never mind, it's gone. Okay. So now, because it was moving, let's look at the next snapshot, right? So now it'll be a little bit closer to the actual center. So now let's say it's, let me use a different color for this. Let's do orange. So now it's, let's say it's negative 10 pixels away from the center, right? So now the next time it runs is going to set velocity to 0 minus center x, which is going to return us negative 10. So now the motor has slowed down. And this is really crucial because the closer it gets to the target, the slower the motor is going to get. And that's really helpful because if it's really far away, it's going to start off fast. Right? So for example, let me erase that really quick. And let's pretend like, I don't know, the camera is like literally right there. Okay, just barely in the field of view. Right? So what's going to happen is, let's say this distance is negative 90. If we run this function, it's going to set the motor's power to negative 90. And it's going to move really fast. But as it gets closer, as soon as it takes that next snapshot and moves through that loop, what it's going to do is slow down and actually get more precise as it gets closer to the target. So now let's pretend like the camera is, that's not centered. Let's pretend like the camera is like directly on the target, meaning 0 or center x is going to be 0, right? So 0 minus 0 is going to give us a value of 0. If the motor's power is 0, the motor is not moving. It's just that simple. And it applies the same in the other direction. If the camera were to be, let's say, positioned like this, the distance is going to be a positive distance. Let's say 30, the motor is going to have a power of 30, meaning it's going to move in this direction. It'll always be aligned. And this is a video from last year, actually. And here you can see the robot like continuously track that. So you see how it is fast when it's initially moving, but it slows down as it reaches. And here there's actually a critical step. So if you notice, the robot actually jerked backward. And with this control algorithm, let's say the robot hypothetically overshoots, right? It can automatically fix itself because let's say it's moving at 30 power and let's say it slightly overshoots and now it's negative 10 in the, or 10 in the other direction. Now the power is going to be negative 10. And it's just going to continue to correct itself until it's 0. And that's the beauty of this code. Okay, so that is part 1, and that is how like the basic logic behind it works. The next video is going to be about implementing this into the robot itself and seeing how it can help with tracking the goal. Thank you.